So, hello, my name is Goran Šibenik, and I'm a student on the Doctoral College Computational Design on Technical University in Vienna. I'm going to present you my research, current state of data exchange between architectural and structural analysis models, a critical review. So first, the popularity of building information modeling, or BIM, is increasing across all the disciplines involved in the planning process. So to achieve the BIM workflow on stage 2 or BIM level 2, it is necessary to achieve a working model-based collaboration. The BIM workflow on stage 3 is using a network-based model. There are also two approaches with BIM workflow. So the first one is closed BIM, which uses a proprietary software, and the second one is Open BIM, which uses a non-proprietary software solution. So why did I consider Open BIM? First of all, the second stage of BIM workflow is using an integrated model, and currently on the market there is no such a software that supports all the existing disciplines involved. The second reason is that European statistics for architecture, engineering, and construction show that the offices in Europe mostly perform the tasks of a single discipline. And therefore, the offices are the key factor when choosing a software solution to be used is usually not the interoperability of the software, but the use of that specific discipline. So why industry foundation classes? Industry foundation classes are a data schema developed by buildingSMART International. It is in practice a standard for Open BIM. It is claimed to be supported by more than 150 software solutions. Out of those, 21 is in the field of architecture and 32 in the field of structural analysis. Also, the software solutions usually support only a subschema of IFC. So the most used subschema is, the subschemas are called model view definitions, and the most used model view definition currently is the coordination view version 2.0, and it's used with IFC 2x3. The coordination view model view definition is used to facilitate the data exchange between architectural BIM, mechanical BIM, and structural BIM. So the base of the research is a previous case study research, which analyzes the transfer of data between an architectural model and structural analysis model using the IFC, or coordination view version 2.0. In order to be used for structural analysis, the building elements must be properly interpreted. And in the case study research, different software solutions have been tested, and none of the software solution gave actually satisfying results. As you can see in the table, the red fields show when the interpretation did not take place. So, after analyzing the case study, the parameters in this workflow have been identified and divided into two groups. The first groups are the actors involved in the data exchange, and those are buildingSMART International as the roof organization, then software developers and the users. The second groups are the processes, which are standards, the existing standards for the IFC data exchange, and the certification that is performed for software solutions. So when these parameters are related to the normal workflow using the IFC schema, we can see that buildingSMART International is directly responsible for the standards, and the certification is performed with the software developers, but based on the certification process defined by buildingSMART International. That's why the buildingSMART is analyzed as the key actor of the whole data exchange. So, industry foundation classes are developed by International Alliance of Interoperability, which is an organization founded in 1996, and since 2008 it is called buildingSMART International. The organization itself has 3 core programs that are users, standards, and compliance programs. The organization is has a relatively complex structure, and the head of the organization is the International Council, which consists from 2 members from each of the chapters, and the chapters are territorial organizations considered with local Open BIM implementation. For the standards program, 3 sub-organizations are involved, so Standards Committee Executive, and Standards Committee Technical Executive. Also, groups and rooms are taking part in the standards process. For the certification process, mostly implementation support group is responsible. So first, the standards process. The buildingSMART international standards are the ones voted as final by the Standards Committee. In the triangle, you can see the main 3 standards that are also an ISO standard. ISO 12006 Part 3 is the international framework for dictionaries, which defines a taxonomy model. The ISO 16739 is exactly the IFC schema, defined in the Express Data Specification language, and the ISO 29481 Part 1 defines methodology and format, while the Part 2 defines the interoperability interaction framework, and that standard is also known as the standard for information delivery manuals. Besides these 3 that are voted also as ISO standards, there are standards that are that are specific model view definitions, and currently there are 2 for IFC4, Design Transfer View and Design Reference View. Besides that, there is a MBD XML standard, which defines the format for definition and exchange of model view definition rules. There is also BIM collaboration format, or BCF, which allows communication between different software solutions based on web interfaces. And there is also an IFC infrastructure that is used for infrastructural projects. So the certification process was, until 10 days ago, performed only for Model View Definition 2 Coordination View 2.0 for the IFC 2x3, but since 26th of June it's done for IFC 4, for the reference view, and for the design transfer view it still did not start. So the certification itself, in this research, the software is addressed only the ones that was certified with the Coordination View 2.0. The certification process itself is divided into 2 parts, the import certification and the export certification, where the export certification distincts actually 3 different disciplines: architectural, building service, and structural certification. Also, the export certification is performed manually and automatically, while the import one is using the calibration files, and also the certification is performed by self-check by a software developer and also by a certification tester. So when first the base research case study research is viewed, and then the described parameters are related to the workflow. In this way, first the missing elements and misinterpretation and missing interpretations are localized, and then they are connected to the parameters described. In this way, the source of the problem is searched for. So the first step was to detect these misinterpretations, and here you can see a wall in one of the architectural programs tested and one of the structural ones, and the IFC4 IFC 2.3 representation. So the information relevant for structural analysis software is first detected in the native architectural software. Then the same information is searched for in the IFC file, and also the IFC files were opened in were viewed in the IFC viewers, and the same information is then localized in the structural analysis software. So the software solutions do not support the whole schema, but only model view definition, and buildingSMART International defines the model view definitions with a concept list. Concept lists are divided into different groups depending on the discipline the software is part of. And here you can see the list of concepts for Coordination View 2.0. The concept lists are also used for the certification process. Something gone wrong here, but it doesn't matter. So this is the geometry concept for the, that was half transparent, so it didn't work. So the geometry concept is we can see here the geometry concept for IFC wall standard case. That is the same wall that was shown on the previous slide, and we can see that here the shape representation body swept solid is a concept which is mandatory. Here is written export and import requirement, but you can't see it. So the body swept solid representation is a mandatory concept for architectural and for structural analysis exports, and also it's a mandatory concept for import in all of the disciplines. The behavior of the software during the certification can be seen in the software solution checklists. They're also provided on the buildingSMART website. And here we can see that the concepts can be supported, restricted, or not supported. The green one is supported, the yellow one restricted, the red one not supported. Here, the architectural software, we can see that the geometry swept solid is restricted, and in the structural analysis software, we can see also that the geometry swept solid is green, so it's supported. However, it is not clear how much of these concepts does the software need to fulfill in order to be certified. So from the results of this analysis, we can see that exported elements are usually using a valid concepts from the Coordination View version 2.0. However, some of the information found in the architectural native software is not exported to the IFC file, sometimes because the concept is not part of the concept lists, or sometimes because IFC schema does not support them. However, all the software solution, architectural software solutions were mostly exporting the same building elements in different ways, and all of those IFC types were valid concepts of Coordination View. The bigger problem was found in the import software solutions, and they were not. The checklists are mostly not behaving the same as the case study solution was not behaving as it is described in the checklists. So it was more related if the building element will be properly interpreted, if it is exported in a certain way from the architectural software, than if it is actually part of the concept. So most of these problems can be traced back to the certification process. The certification does not necessarily, the software solutions do not necessarily have to support the provided concept lists. Users and software developers are not really part of the model view definition concept lists. Also, that could be maybe solved by providing previously an IBM information delivery manual, which would describe the exact exchange requirements for the specific exchange. Also, the certification cannot be regarded as a valid interoperability indicator of the software. So, In the end, there we can see that there is a huge gap between the IFC products and standards and their implementation in the software solutions. In order to achieve the BIM workflow on the stage 2, the technology issues must first be resolved, and in order to do that, all three actors need to work together.